you'll be able to see it. Is it visible from where you are?
Yes.
Good. So we can continue. My name, you guys, you know, my name is Professor Julius Oyugi, and already I've seen on the chat, people are very excited about herpes viruses. So we shall have herpes as a makeup class, but today we want to touch on to a different group of viruses. Bear with me, so we shall get time to complete the other herpes viruses. They are very interesting viruses, as I told you last time. Very friendly viruses. They live in us. They wait, and we die with them together, go in the grave together. So without killing us. So they are very friendly viruses. And so we shall today we'll go and talk about a different family of viruses. And but then we shall get time to talk about herpes as well. Not today. So let's look at another family of viruses. We call them Picornaviridae. And based on the name of these viruses, would you tell me whether this is a family of RNA or DNA viruses? Based on what you are seeing on the screen, can you tell me whether this family of viruses is viruses of DNA or RNA? Quick one, everyone. RNA or DNA? Everyone. RNA, is this an RNA or DNA viruses? I can see, oh, hey, somebody, the state. You know, some of you are logging in with very weird name, deep state. Is that somebody's name? Somebody's called Nobel Malil. Okay. RNA, 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 RNA. Good. So it's very easy to know that these viruses are RNA viruses by just looking at the name. If you read the name, there's Pico, and then there is after the word Pico, then you see the word RNA, so you get the sense that these are actually RNA viruses. Good. So as usual, I want to jump your mind. Can you tell me what do you know about Picornaviruses, other than the fact that they are RNA viruses? Can we see on the chart what are Picornaviruses? They are naked viruses. They cause cancer. Oops, cancer. I want to get an example of which Picornavirus cause cancer. That may not be true. They are small, correct. These are small viruses. Poliovirus is one of them, correct. Let's continue. Single-stranded, we shall see that they are enteric. Yeah, some of them are, some are naked, icosahedral. They have non-envelope, icosahedral, positive sense. Fecal oral. What is fecal? I thought it is fecal. Fecal as F-I-C-A-L, not F-I-C-K-L-E. Mulki, umesikia hiyo? Positive sense, replication occurs in the cytoplasm, yeah, because of RNA viruses, human are the only natural host. We shall see that today. What else do you know about this virus? They're single-stranded, yeah, correct. Let's continue. I want to see responses from everybody. So, icosahedral non-enveloped. Hassan Omar is laughing, laughing tears. I'm wondering why Hassan is laughing. Hassan, what's making you laugh? Stable under wide range of pH except rhinoviruses. At least that's good answer. You know that rhinoviruses are part of Picornaviruses. Anything else that you may want to tell us? I hope everyone has responded, said something about Picornaviruses. Onyango says, I'm the only one who can't hear anything. Oops, is that true?
We can hear you.
But Onyango can't hear. Onyango, wewe unavuka samaki wapi? You're under the lake. Onyango, tell me, are you hearing me now? Yes. Kelsey can hear me. Who cannot hear me? Can I see from the chat? Who cannot hear me? Is there anybody else who cannot hear me other than Onyango? Yeah, people are saying they can hear. Onyango, nunua data bundle bwana. Sasa wewe hata mwenzako anakuambia ununue data bundle. Una data bundle? We can hear. So I would think that Onyango has a problem whether with his phone or where he is, he's got poor network, but I think everyone can hear me. So let's go and talk about Picornaviruses. So Picornaviruses, we shall look at two things in general during this lecture. Number one, we want to look at the characteristics of these viruses that are called coronaviruses. And then we shall just look at a few of them today. The rest of them you can actually be studying on your own. And then that is what is expected of us. Students, we're supposed to give 75% of staff, and then 25% we get additional 25% from you students as homework. So let us look at the general characteristics of these viruses that we call Picornaviruses. The Picornaviral family, derives the names, as you had said earlier. Pico means small, right? And the next 2-3 letters are RNA, which means that these are, small RNA viruses. So we should be aware that these are small RNA viruses. They are very small to the extent that the diameter is about 30 nanometer. 30 nanometer is so small. If you look at the picture on the right-hand side, that is how the electron micrograph, how these viruses look like, under electron micrograph. You can imagine electron micrographs as such a huge magnification that, what you are seeing, you can only get a bunch of these viruses together for you to be able to see the viruses. So these are very small viruses, they're RNA viruses. The other characteristics of these viruses, as we are going to talk about more about the family, the genera, and the range of viruses that belong to this family, we now know that these viruses cause a wide range of diseases in human beings. These diseases, start from the range from very severe disease like the paralysis of the lower limbs or aseptic meningitis. Those are very severe diseases in humans, to very mild disease such as respiratory illnesses, undifferentiated febrile illnesses. These are illnesses like fever, headache, which just disappear. Conjunctivitis, severe generalized disease of the infants, vesicular and xanthomatous skin lesions. They can also get skin lesions as a result of infection with these viruses, and so they cause quite a range of diseases in humans. But the most severe diseases here are the paralysis of the lower limbs and aseptic meningitis. This is what we know as far as diseases caused by these viruses are concerned. The good news is that majority of infection with Picornaviruses are subclinical, meaning that you will acquire the virus, they will never present symptoms, your body will be able to clear them without you knowing. So you may never know that you've been exposed to one of the Picornaviruses because they are fond of causing some clinical infection. So that is something that you may need to know. The other thing is that because they cause a range of clinical symptoms, as it is very difficult to use symptoms alone to distinguish, say that this individual is suffering from these picornaviruses. The only, the definitive diagnosis after clinical presentation is laboratory diagnosis. So you really need to, if a patient comes to you with symptoms that we're going to talk about, some of these viruses, then you need to be able to take specimen from these patients and carry out laboratory tests. The most serious disease caused by enteroviruses is caused by a virus called polio, and polio causes a disease called poliomyelitis. And we shall look at this disease later. I was just checking the chart. So these are some of the general characteristics of Picornaviridae. In terms of classification of these viruses, Picornaviruses are classified in the family and they're referred to as Picornaviridae. These viruses are actually then further classified into genera. There are about 5 genera amongst the Picornaviridae family, 4 of which cause human disease. The last one does not cause human disease, but for purposes of those diseases which are common, which are relevant to us, we shall confine them to 3 genera, which are, number 1, the enteroviruses, the rhinoviruses, and the hepatoviruses. Note that hepatoviruses, where an example is hepatitis A virus, will be discussed under hepatitis viruses, and therefore we are not going to discuss it in today's lecture. So you will come to hear more about hepatitis A viruses when you're being taught about hepatitis viruses. But going back to the other genera, we have, the enteroviruses. These are, polioviruses, which have 3 serotypes. There is poliovirus type 1, poliovirus type 2, and poliovirus type 3. Then there is the human Coxsackie viruses, which will also be discussed when we are talking about gastrointestinal viruses. So for today, you may read it on your own, but it will come later on when we're talking about viral gastroenteritis. Then we have human echoviruses. So the viruses which are classified under enteroviruses are usually transmitted through fecal oral. And then the second genera, which is rhinoviruses, these viruses, this genera has got about more than 100 serotypes of human rhinoviruses. Rhinoviruses, they cause influenza-like disease, like homa, running nose, feeling body general weaknesses, things like that. This genera contains about 100 and over, serotypes of Picornaviruses. So these are the 3 main, genera of Picornaviruses. Not 3 main, but we talked about the 5. 4 cause human diseases. The last one does not cause human disease, but the ones which are more important in terms of the diseases that will be coming across in your day-to-day life as a clinician belong to the 3 genera: the enteroviruses, rhinoviruses, and hepatoviruses. And as I said earlier, hepatitis A will be discussed when we're talking about hepatitis viruses. Rhinoviruses will be discussed today, if we get time, and then Coxsackie viruses will be discussed when we're talking about viral gastroenteritis. So these are the, members of these viruses. So when we, let me see this. So looking back to epidemiology and history of picornaviruses, we are told that these picornaviruses, which I have mentioned to you, belong to 4-5 genera, and I've given you examples of which viruses are in each genera. We are being told that these viruses are found globally. Wherever you go, whether you are in the US, UK, Africa, Asia, you will always find these viruses to be found there. They don't have restricted distribution to one geographical region. That's one thing that we should understand about these viruses. So the other thing that we need to understand is that transmission most commonly occur through fecal-oral, that is, eating or drinking contaminated food or water with a virus, contaminated with the virus, one of the picornaviruses, or they can also be transmitted through respiratory route. So we talked about rhinoviruses. Rhinoviruses are mainly transmitted through respiratory route, sneezing and touching surfaces that has droplets from someone who is sneezing and coughing. So those are the main mode of transmission of these viruses. And remember, when we talked about the history of viruses last time, we mentioned the fact that in 1898, the first animal virus we discovered was foot and mouth virus, and foot and mouth virus is one of the members of the picornaviruses. So these viruses have been there for years. They have been there for many years. Poliovirus, which is one of the most deadly viruses belonging to this family, was first isolated. So remember, I'm using the word isolated and identified in 1908. The virus was isolated and identified in 1908. It doesn't mean that the disease due to polio was identified in this year. This is the first time the virus was actually identified in the laboratory. But poliovirus had been causing epidemics for years from the 17th century. And so I want us to now take a look at poliovirus, one of the most deadly viruses in the family of Picornaviridae. And I'm sure that most of you are wondering, when you see children or adults walking with the deformed legs, some people think that most of them are due to accidents. But the truth is that most of those people who are walking in crutches or with deformed legs probably had infection with polio when they were young, and because this virus is able to attack the motor neurons in the brain, they damaged the motor neurons, and that led to the deformation of the legs, and therefore they are now suffering from paralysis of the lower limbs. So, as we have mentioned earlier, poliovirus belong to the genera of enteroviruses, and I think is considered one of the most important virus in that group because of the disease that it causes in human beings. Historically, we are now aware that polio disease had been reported all the way from 1800s. It used to cause paralysis of the lower limbs as early as 1700s. And if you go to Egyptian archaeologists that got information from the Egyptian tombs, there were drawings showing that this disease had been there for as long as human beings have been around. The virus has these serotypes. We have poliovirus 1, we also have poliovirus 2, and we have poliovirus 3. So there are 3 different serotypes of poliovirus. Now, let's look at the epidemiology of poliovirus. So humans are the only known reservoir for poliovirus. I'm not sure whether I may have explained to you when we did introduction to virology that viruses, there are viruses which are have short host range, and those viruses that have long host range. The ones that have short host range only infect one host. The ones that have long host range infect more than one host. When I talk about hosts, I'm referring here to humans is one host, maybe dogs is another host, cattle is another host. So for poliovirus, they only infect humans only, and that makes it a very easy virus to eradicate if we were able to perform to eradicate this virus. Transmission is fecal to oral, so we normally acquire poliovirus either by drinking contaminated food or water, then we get infected. We're also told that in temperate lands, now these are regions of the world that have defined weather seasons like summer, winter, fall, and autumn. People like us who live in Africa, we only experience, the weather pattern is divided into short and long rainy seasons and dry spell. So these climatic conditions, they normally determine, the outbreak, the periods when diseases are high. And for poliovirus, we're told that most cases occur during summer when it is hot. Because a lot of people go out, hanging out, dining out there, and there's also a lot of people may get in contact with the virus through the environment. Poliovirus, has a worldwide distribution, but this since the advent of the vaccine, we're going to talk about the vaccine for polio in the next few slides. But the poliovirus has been eradicated in most part of the world. There are only a few parts of the world that are, polio free. I'm seeing my time is 1 minute to 4 o'clock. Can we take a break for the sake of our Muslim brothers and sisters and come back at 4:15? Is that okay?
Yes.
Yes. So please pray for us. Every one of us need prayers in our lives. We'll come back at 4:15. Asanteni sana. So I hope that our brothers and sisters also prayed for us. And now we are, blessed with no evil spirits hanging around us. So we're talking about poliovirus, and we have looked at different aspects of the virus. The last slide was the one that I'm sharing with you, which is on the epidemiology of the virus. And we have just learned that, this virus is found globally. It is found globally, not now. I think it is important to remember that. It used to be found everywhere globally, but because of vaccination, which we're going to look at in the next few slides, polio now remains in some countries of the world and not all countries of the world. So it has been almost eradicated thanks to the vaccine, innovations that now can protect us from infection with poliovirus and developing poliomyelitis as a disease. So let's also look at the pathogenesis. So remember, we talked about pathogenesis of viruses before, and each virus that we talk about moving forward, we need to understand how does this virus get into human beings, where does it cause, where does it damage that leads to us either getting disease, or where does it hide that makes the virus not cause the disease but stay in us, without causing any, clinical manifestation. With poliovirus, we now know from the previous slides that enteroviruses, where this virus belongs to, is transmitted through fecal-oral. So the virus enter our body via the mouth and get into our body through the alimentary canal. That is the stomach, the small and the large intestine. But what happens is that as soon as you swallow the virus, through the mouth, the virus actually starts immediately replicating. So you swallow a few copies of the virus in water or contaminated food. As soon as it gets into contact with your mouth, the virus starts replicating from the throat to the stomach and the small and the large intestine. As it replicates in these organs of our body, part of it is shed. So when you pass stool, you will shed some of those viruses to the environment. But some of the viruses actually, invade the bloodstream. So during the replication in the alimentary canal or the gastrointestinal canal tract, rather, some of the viruses are shed through feces, others get into the bloodstream. And once they get into the bloodstream, they then venture into the lymph node tissues and they possibly travel to the central nervous system. And the central nervous system, here, brain is part of the central nervous system. So in case any of these viruses are able to infect and replicate within the cells, the central nervous system, such as the motor neurons of the brain, the virus actually would destroy these cells, the motor neurons. And once that happens, that is what then causes you to lose your senses of coordinating the lower limbs, and you end up with the paralysis. So we talked of polio as causing a devastating disease called paralysis of the lower limbs, and that occurs as a result of these viruses killing the motor neurons that are found in the brain. So that is how this virus called polio is able to cause disease in us. But as we're going to see, under clinical manifestation, so not all poliovirus infection lead into disease. So we are told that when you acquire the virus for the first time through fecal-oral transmission, there's an incubation period from 4 to 35 days. But in most cases, you tend to develop disease within 7 to 14 days. That is the average. However, please note that we said earlier that the most infections are asymptomatic or inapparent. So most people who get infected with poliovirus, they will never know that they have been infected. The body is able to clear the infection, and you recover without showing any signs and symptoms of polio disease. However, for some individuals following infection, you can either present, with so the outcome of infection with poliovirus can be, divided into 3 categories. The outcome of exposure for poliovirus can be divided into 3 categories. The first category is what we are calling abortive poliomyelitis. The second, category is called aseptic meningitis, and the third category is what we call paralytic poliomyelitis. And we want to look at each of these, outcomes of polio infections in the next, slide. So what is abortive poliomyelitis? We are told that this is actually the mildest form of polio disease. It's very non-specific. It's very hard to for a doctor to establish whether someone is sick with polio disease, because the manifestation, how this presents, is like you present with influenza-like disease. So you are having a running nose, you are sneezing, a bit of sore throat, and that is it. So you recover within 1 week without developing any symptoms other than this. And because the virus does not reach the central nervous system, you don't end up with the diseases of the paralysis of the lower limbs. So this is what they call abortive poliomyelitis. So the infection is aborted because your immunity is able to fight and clear the virus. Then the next outcome of poliovirus disease is what we are referring to as aseptic meningitis. Aseptic meningitis. Here, the symptoms are slightly different from abortive poliomyelitis in the sense that you present with stiffness of the neck, you feel a bit of back pain and a bit of weakness on the legs, and this lasts for 2 to 10 days, and you recover and completely recover. So again, your body is able to fight the disease, but the symptoms here are slightly more distinguishable than when you had abortive poliomyelitis. So those who actually end up with the polio disease are those who the outcome of infection can be grouped as paralytic poliomyelitis. And we are told that, within 2 to 3 days of minor illness, you present with, fever and flu-like symptoms, and then which resolve, and then after a few days, then you start feeling irritation, meningeal irritation. The fever has disappeared, but now you start feeling like something is irritating your, cervical, spinal cord and stuff like that. Flaccid paralysis is actually then characterized by cramping of the muscle pain. So you start getting pains, the muscle pains on the lower limbs. You start getting spasms. You have, coarse twitching, and tendon reflexes are diminished. So the ability of the tendons to control the movement of your legs, become lower and lower, and to the extent that now you lose the ability for the tendons to hold the bones of your legs, and you lose also the coordination of movement of your legs, because all the coordination actually occurs from the brain. So patients do not show any loss of sense or cognitive changes. So whereas this virus infects the brain, your mind is steady. You don't behave like a madman, or you don't show like something has interfered with your cognitive abilities. Some people actually do recover from infection, this paralytic poliomyelitis. But if the symptoms continue for more than 6 months, then you end up with permanent paralysis of the lower limbs. So these are the 3 outcomes of infection with the 3 different types of poliovirus. So if you get a patient who is presenting with those symptoms of polio, whether abortive polio or aseptic polio or paralytic polio, again, it is important that the only way you can know whether they are infected with polio is to carry out laboratory diagnosis. And to carry out laboratory diagnosis, you need to take swabs, and these swabs are taken rectal swabs, or you can also take stool samples, because remember, when we're talking about the pathogenesis of polio, we said that when you get the virus into your body, the virus replicates in the stomach, the small and the large intestine, Some of the viruses are released in the stool. So the specimen of choice for poliovirus diagnosis, the stool sample or the rectal swab. I know that these viruses are actually infect the central nervous system, but you cannot use cerebrospinal fluid as the specimen because you rarely get this virus in the cerebrospinal fluid. So if you want to confirm the infection with this virus, you need to get stool sample from the patients. And when the stool is being collected, it has to be submitted to the lab immediately. And usually, they used to do, what they call tissue culture before, but nowadays all the tests done to confirm polio virus infection are due to what we call PCR, polymerase chain reaction. They are very rapid and accurate in determining infection with poliovirus. So is there treatment and prevention for polio? Treatment for polio is not there. So like most viral diseases, if you get infected with polio, you just hope that your immune system will play its part and clear the virus, but there is no treatment. How about prevention? Yes, we can prevent ourselves from getting polio. And number one, if we practice hygienic practices, because we know that poliovirus is transmitted through contaminated water and food. But number two, we have very good vaccines for poliovirus. And these vaccines have been there for years. The vaccine have been licensed. The first vaccine is called Salk vaccine, which is inactivated polio vaccine. So IPV stands for inactivated polio vaccine. And the other vaccine is Sabin vaccine, which is called oral polio vaccine. Both of these vaccines are good. The Sabin, which is oral polio vaccine, is live attenuated virus. So it has polioviruses which are alive. They have just been changed or attenuated. They are administered through oral route, but this vaccine has been discontinued because it had some issues. Those who are vaccinated with this vaccine, the virus would actually cause infection of the stomach and the small and the large intestine and behave like the wild type virus and is shared into the environment. So it was found that some people would actually acquire the vaccine strain of the virus when they drink or eat food contaminated with this live virus, which has an ability to change to wild type virus. So it's no longer in use in most part of the world. However, the Salk vaccine is the one that is still being used to eradicate polio in countries where polio has not been eradicated. So my question to you, why, what is the, can someone tell me the difference between the two vaccines? So what is the advantage of, I think the question is, what is the advantage of using inactivated polio virus? What is the advantage of using inactivated polio virus? I want to see responses. It has all the three serotypes of poliovirus. That is good. Which other advantage? Why do we still continue using it? Why do we still continue using the inactivated polio vaccine? Less chance of virulence, correct. Has higher seroconversion, minimal side effects. It is safe. Yes, it is safe. It means more security. I'm not sure what the word security means. No side effects, not necessarily cannot infect. Yes, it cannot infect because the viruses are killed. Has a longer shelf life. I'm not very sure about that. may not mutate. Yes, that's correct. And yes, so the inactivated polio virus vaccine is safe because the virus in the vaccine are killed. They don't have an opportunity to revert to the wild type, and a characteristic which the oral polio vaccine can actually acquire. The viruses in the oral polio vaccine are live, and sometimes 1 in about a million chances these viruses can revert to wild type and can cause disease in humans. So, those are the vaccines that are available for polio. But remember, we are still fighting with polio. We have not been able to eradicate polio for a number of reasons, although we have the vaccines available for us. So that is it about poliovirus. I want you to please go and read about immunity. I want you to read about immunity against this virus. So if you get infected with poliovirus type 1, are you immunized against poliovirus type 2, or are you immunized against poliovirus type 3? So I want you to go and read and understand how your body, plays around with these different types of poliovirus. So I want you to go understand the poliovirus from immunity perspective. So finally, let's look at the rhinoviruses. So remember, I said that today we are only going to look at poliovirus and rhinoviruses, just because the other viruses will be discussed when we're looking at other groups of viruses like hepatitis and viral gastroenteritis. And so, rhinoviruses are the most common cold viruses. Remember, when someone has a cold, it's usually very difficult to know what they're suffering from, because there are a number of viruses that can cause what we call cold, or common cold rather. We have, viruses like COVID, coronaviruses that cause cold. We have influenza viruses that cause cold, but rhinoviruses are the most common cold viruses. Majority of the cold that we suffer from are due to rhinoviruses. Again, in terms of distribution globally, these viruses are distributed across the globe. There is no restriction anywhere where we can say that rhinoviruses are only found in Africa and not found in the US. That's as far as the distribution is concerned. The transmission of rhinoviruses is via aerosol droplets. So you sneeze, you cough, and you pass the droplets to the next person, and they're able to become infected with these viruses. Additionally, we are told that there are over 150. There are over 150 serotypes of rhinoviruses, and these have been grouped into 3. So we have rhinoviruses species A, B, and C, and each of these groups, if you add the serotypes altogether, there are over 150 of them. These viruses, they infect humans, but they also have the ability to infect other animals like gibbons and the chimpanzees. Chimpanzees are the closest animals to human beings. So rhinoviruses can also infect chimpanzees. So clinical manifestation. So rhinoviruses, as we say, are the most common, common cold viruses that cause common cold. The incubation period is between 1 to 4 days. So within a very short time, you start presenting with the illness. The symptoms include nasal discharge. So you start having running nose, nasal secretions. You start sneezing, and you develop sore throat, which sometimes can lead to coughing. These are very common symptoms caused by other viruses as well. Some people end up with fever, um, um, with upper respiratory tract. But the good thing is that all infections due to rhinoviruses resolve within 1 week or so, depending on your immunity. So very right chances that one will die because of rhinovirus disease. Pathogenesis. How do these viruses end up now causing running nose, sore throat, and sneezing? The virus usually enter through the upper respiratory tract, and we're told that the high titers of the virus in the nasal secretion is found within 2 to 4 days. That is, those when you start when the virus gets into your body, they replicate so fast that you end up with very high titers within 3 to 4 days. And as they replicate, that destroying most of the cells that are lining these surfaces of your, the nose, the throat, and yeah. So thereafter, the viral titers falls after 4 days. The amount of virus that can be found starts, going down. Although in some people, I think because of the immunity, the virus has been recovered after 3 weeks. Ideally, after 4 to 5 days, you're not supposed to. You should be having very low virus in the throat and the nasal secretion. But some people, because of immunity, you can recover this virus, up to 3 weeks post-infection. So they say that there's a direct correlation between the amount of virus in the secretion and the severity of disease. So when you have the peak replication time of the virus, that is when you find people presenting with the symptoms. Symptoms, you start seeing symptoms at the virus level amount increases, and the symptoms also go down as the amount of virus also go down with time. The type of infection that these viruses cause is called localized infection. The type of infection is called localized infection, meaning that these viruses do not go beyond the nose, the throat, where they infect. That is where the infection actually ends. So we are also told that these viruses, they rarely cause lower respiratory tract disease in people who are healthy, although certain individuals with immunosuppression, in certain cases they can end up with rhinovirus causing lower respiratory tract. But in healthy individuals, the infection is maintained in the upper respiratory tract. In terms of treatment for rhinoviruses and treatment and prevention, currently there are no antiviral vaccine therapy available for these viruses. Though people take all sorts of things as a remedy, those things that they take have never been approved. I remember during COVID, people were taking all sorts of things like tangawizi, lemon, I don't know what and what. Those are things which people don't normally take when there is no treatment. But from where I sit, there is no antiviral drug that has been approved for treatment of viral diseases. Additionally, we don't have a vaccine currently available for treatment of rhinovirus disease. Someone is asking me, what is viral titer? Viral titer means if we take a swab from your throat in a liquid, we are able to count how many virus is in 1 milliliter, of secretion from your throat. So a good example is if someone who is having, if you take 2 swabs from 2 different people, and one has got 10 rhinoviruses per milliliter of the secretion, and another one has got 1,000 rhinoviruses per milliliter of secretion. The person who has got 1,000 has got high viral titer than someone who has 10. Yes, so someone is talking about can we have an oral route mode of transmission for poliomyelitis? Yes. So if you kiss someone with polio, you get polio. This has been a common thing happening with mothers, who get infected. They transmit the virus to their babies. Even babies who are vaccinated were also transmitting the virus to the mother through the saliva. So you can transmit oral polio vaccine through kissing. It's not just through fecal oral transmission. So yeah, good. So that brings me to the end of this lecture today. So we shall be covering some of the Picornaviridae, as I told you. Hepatitis A, we shall cover hepatitis A when we're talking about hepatitis viruses, Coxsackie, A, B, we shall cover them when we're talking about viral gastroenteritis. And so I think that brings me to the end of this lecture for today. I'm hoping that we shall be looking for time to have a makeup class for the herpes viruses that we didn't cover. But I will actually arrange this with the supervisor. Good. So thank you very much. Enjoy the rest of the day. I can see it is almost 5 now. I think I would want to end this class by saying Asante Sana.
Thank you.